Hello my friends and business partners from around the world, welcome to my channel. In this video I speak about Krons Reduction applied to electrical power systems. Our objective is to calculate the line currents IA, IB and IC, but when there is a ground system or a neutral wire, the ground system of neutral wire is going to influence the value of the currents IA, IB and IC. So, to properly calculate the value of the line current, we need to discount the influence of the neutral wire or grounding by using Krons Reduction. Let's understand the problem. Here we have modeled the generator as three power supplies, VAN, VBN and VCN, and three impedances that represent the copper wires of the generator, ZAG, ZBG and ZCG. Here we have modeled the transmission line as a series impedance ZAA prime, ZB B prime and ZC C prime, and the mutual coupling between them. ZAB is the mutual coupling between line A and line B, ZBC and ZCA. And here we have represented the mutual coupling between the lines and the neutral wire as ZAN, ZBN and ZCN. The load in Y is represented by the impedances ZA prime N prime, ZB prime N prime and ZC prime N prime. And the neutral wire is represented by an impedance Z N prime N, and the current that flows through the neutral wire is IN. We wish to calculate the values of the currents IA, IB and IC. How are we going to do that? Let's use Kirchhoff's law. Kirchhoff's law says that VAN is going to be equal to the voltage drop here, IA times ZAG, plus the voltage drop here, IA times ZAA prime, plus the voltage drop here, IA times ZA prime N prime. So, we write it, IA ZAG plus ZA A prime plus ZA prime N prime. Okay, now we have to compute the influences of the mutual coupling. IB is going to influence this line here, so IB times ZAB. The same is going to happen when a current passes here. It's going to influence through the mutual coupling the current that passes here. So we model it by IC times ZAC plus now we have to compute the effect of the neutral wire. There's going to be a voltage drop here, IN times ZN prime N plus the mutual coupling between the neutral wire and line A plus ZAN. Okay? We are going to do it for all the lines. We did here for line A. We are going to do the same thing for line B and for line C. And what we get is a matrix. Okay? Is a matrix. But before arriving at the matrix, let's model this entire thing here as the impedance ZA. Okay? So, assume that ZA is equal to ZAG plus ZAA prime plus ZA prime N prime. if we do that, we are going to simplify our calculation. And the same is going to be done for ZB, ZBG plus ZB B prime plus ZB prime N prime. And the same thing is going to be done for ZC, which is going to be equal to ZCG plus ZC C prime plus ZC prime N prime. Okay? We are going to do that, okay? Instead of writing ZBG, ZBB prime and ZB prime and prime, we're going to write this. And instead of writing ZCG, ZCC prime, ZC prime and prime, we're going to write this. And we are going to find the following matrix. I invite you to try in your house and to see if you arrive at the same results that I am arriving. Let's see if we speak the same language. Let's see if we find the same results. Okay? We are going to find a matrix of the sort V equals to Z line times the current plus the current of the ground or neutral wire times Zn. Okay? And when we do that, we find the following matrix: VAN, VBN, and VCN equal to ZA, ZA, ZAB, ZAC, ZAB, ZB, and ZBC, ZAC, ZBC, and ZC. Here, IA, IB, and IC, plus the influence of the neutral wire, which is going to be equal to IN, ZN, N prime, ZN, N prime, ZN, N prime plus ZAN, ZBN, ZCN. Okay? Do you guys understand what I said? Here, the voltages, VAN, VBN, VCN. And here ZA, which is ZAG plus ZAA prime plus ZA prime and prime. ZAB, which is the mutual coupling between line A and line B. ZAC is the mutual coupling between line A and line C. Okay? Try to do that in your house and you are going to find the same result. Now that we have this, we can create the other matrix, the matrix that is going to enable us to calculate the line currents. Our objective is to calculate the line currents. So let's do it. Let's calculate the line currents. Alright, now VAN, VBN, and VCN, VN prime N. Okay? Now we have the influence of the ground inside of the matrix. ZA, ZAB, ZAC, ZAN, ZAB, ZB, ZBC, ZBN, ZAC, ZBC, ZC, and ZCN, and here the ground, ZN plus ZA, AN, ZN plus ZBN, ZN plus ZCN, and ZN. And the currents now, we have to multiply it by the current. The currents will be IA, IB, IC, and IN. Okay? We don't know beforehand the value of V and prime N. We don't know. We don't know this voltage drop. So what we need to do is to get rid of it. Remove it of the equation, because if we don't know it, it's not going to help us. How do we do that? We apply Krons reduction. Okay? We apply Krons reduction. And what we want is to have only this part here. Only this part. How do we apply Krons reduction? Okay? How do we apply Krons reduction? I'm going to teach you. It's easy. There is a very simple formula that's going to enable us calculate the equivalent impedances that result from the application of Krons reduction. The formulas are these. Z x x prime is going to be equal to zx x minus zxn squared divided by znn. Alright? Very simple formula. And zxy prime is going to be equal to zxy minus znn zxn times zyn. Alright? Do you guys get it? Very simple, isn't it? We are going to use these expressions to find the following matrix. We had a 4x4 matrix and we want a 3x3 matrix. Okay? Once again, we had a 4x4 matrix and we want to reduce it to a 3x3 matrix. And we applied Krons reduction and we find this matrix here. VAN, VBN, VCN equals to ZA prime, ZAB prime, ZAC prime. ZAB prime, ZB prime, ZBC prime, ZAC prime, ZBC prime, and ZC prime. And here we have the currents that we want. IA, IB, and IC. Okay? We applied Krons reduction in that 4x4 matrix and we arrived at this 3x3 matrix. It is easy. Now, to find the currents that we want to find, we simply invert this matrix here. Okay? So let's do it. We have to invert this matrix here. And when we invert the matrix, we find exactly what we wish to find. So, how do we do it? It is simple. It's going to be IA, IB, IC equals to ZA, A prime, Z, AB prime, ZAC prime, ZAB prime, ZB prime, ZBC prime, ZAC prime, ZBC prime, ZC prime. We take the inverse. We take the inverse of this matrix. Okay? We don't want this matrix here. We want the inverse of this matrix. And after getting the inverse of this matrix, we multiply by the voltages. VAN, VBN, VCN. This matrix here is the impedance matrix, but what we want is the admittance matrix. When we invert the impedance matrix, we get the admittance matrix, and when we multiply the admittance matrix by the voltage matrix, we get the currents. And this is the solution of our problem. This is what we want. So my friends, this is the video that I wanted to make. I hope you guys enjoyed and learned through it. And if you guys want to talk to me or book a lesson, simply leave me a message. Goodbye!